Hello, everybody. So, you guys should have just read chapter 4 about light waves online on newstu.com, or you could have read the PDF version. And the level of text that we read in our class is always level JK. So that's why that's the PDF version that's available on the blog. But if you guys have not read chapter 3 yet, do that first. I'm gonna review with you. So first, read chapter 4. Sorry if I said chapter 3. It's chapter 4 about light waves. So you guys read chapter 3 last week on your own, and I did not do a video, so I'm sorry about that. I'm gonna try to do a video for every chapter that you read. So in this chapter about light and light waves and how we see light, first of all, how do we see light? With our eyes. We don't smell light, we don't taste light, we see it with our eyes. And actually, when we see light with our eyes, we are seeing energy. So when we see light, we are seeing energy. Ooh, I forgot my magnets to put up on my board. All right, so every time that we see light, we're seeing a form of energy. All right, and when we see light, there's these little itty bitty individual tiny particles that are called photons. So I drew a little picture. All right, so when we see light, there are these tiny particles. This is like a flashlight. All right, there's tiny particles and they're called photons. Little bits of energy are called photons. And when those photons move in waves, that is called light waves. So if we were to have a flashlight, that stream of light, if we were to zoom in and if we could see light waves, all right, this is what they're made out of. The photons move in waves, and that's also called light waves. I got my flashlight here. All right, so light waves and sound waves move differently. When we were in school still, before school closed, we started learning about sound waves. We haven't really learned about light waves yet, but when we've been going over vocabulary in the classroom, sound wave and light wave are two of our vocabulary words. And when I drew them on the board, I was kind of drawing them the same way. All right, let me get my markers. So, I was drawing them like this to help you guys get a good idea of what it looked like. But light waves and sound waves look different. I'm gonna try to get a slinky tomorrow so I can show you guys a good visual, but I don't have any slinkies today. So, sound waves are kind of all in the same line. They're just spread apart, smushed together. Spread apart, smushed together. That's a sound wave. And a light wave is still the squiggles, but they move up and down. So the difference is that light waves and sound waves are similar, but they move differently. All right, and how do they move differently? Is that when we shine a light, turn my flashlight on. When we shine a light, it can't travel through things. On the other side, look, if I shine a light on my face or myself, can you see it on the other side of me? No, you can't, okay? So here's my little visual. When we hold up a flashlight like this, and it hits a wall, we can't see it on the other side. There's still waves, but they don't go through objects. But sound travels through objects. Remember in the classroom, I had you guys put your ear up against the wall, and then I knocked on it. All right, so sound travels through things. So if you're walking in the living room and you stub your toe, you kick something, and you yell, ouch, that sound is gonna travel through the wall, and your mom or dad is gonna hear it on the other side of the wall. So sound travels through objects and light does not travel through objects. All right, and there's different kind of waves. I think in the brain pop video, it's gonna talk about some different kinds of waves of light. And in your chapter, there's some really good pictures for you guys to look at on the chapter book. So if you're on News to You Online, zoom in and get a good look at the picture. Or you can click on the PDF and print it out so you can see it bigger. But there are some light waves that we can't see, like X-rays. If you've ever gone to the dentist, which I'm sure most of you have, once a year you have to have X-rays done on your mouth. That machine uses light, but it's rays that we can't see with our eyes. So an example of a wave that we can't see is an X-ray. All right, and I'm gonna upload a video of myself doing an experiment, hopefully, that you guys can do at home. All you would need is flashlight, white paper, and a piece of glass, so you guys can see the rainbow. In your chapter that you just read, you learned that the rainbow has lots of different colors that we can see. The acronym is Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Those are all colors that we can see with our eyes and that we can see in the rainbow. All right. Which color has the longest wavelength? Red. What happens when light changes to a different color? The wavelength changes and the frequency changes, okay? So wavelength, the wavelength changes and the frequency changes. Oops, let me do that again. The wavelength changes and the frequency changes. All right, so that was our review of the chapter. I hope you read it first, and that was our review. And now you guys can go do your chapter fill in the blank and answer your comprehension questions about the chapter. And hopefully I can get that experiment up for you for Monday today, or if not, I'll have it up for you on Tuesday. I miss you all. Bye.